Hey, this is Bottom, and we're going to be talking about another example in game theory. And it's, again, going to be Atlas Reactor specific. So this is example 3. It's about Su-Ren Ults. And this may seem pretty specific, but this is going to be a pretty... These kinds of situations are going to come up, not because they're all about Su-Ren Ults, but because in general it's a situation where people are trying to match their choices, sort of like an even and odds or a penny matching game. But the payoffs are slightly different depending on whether you win with 2 1s or 2 2s. So let me show you how this goes. So here's the situation. So you've got a Rask, you've got a Nyx, and the Nyx is further back than the Rask. And you've got a Su-Ren here, and you've got a Lockwood. And both Rask and Nyx are going to be low HP. And so what that means is that Lockwood can shoot either of them and kill either of them. But of course Su-Ren, she can ult either of them and protect them. So of course Su-Ren is trying to guess which one Lockwood is going to shoot, and she's going to try and protect that one. So here's the catch, is that it's slightly better for Su-Ren to ult Rask than it is for her to ult Nyx. Because if she ults Rask, then the explosion goes off and it actually does something. Whereas if she ults Nyx, well, the explosion goes off and probably gives away his position and doesn't hit anybody. So, if everything else were the same, Su-Ren would rather be ulting Rask. And so similarly, Lockwood would rather that Rask not be the one that's ulted. So here's how we're going to make the payoff matrix. We're going to say Lockwood is here, Su is here. And so Su can ult either Rask or Nyx, and Lockwood can shoot either Rask or Nyx. So I'm going to say that if they don't match, if Lockwood decides to shoot Rask, but Su-Ren decides to ult Nyx, I'm going to give this a -5, because someone is dying, and that's really bad. So if Su-Ren ults Rask and Lockwood shoots Rask, Rask lives, but on top of that, he's got the ult, so I'm going to give that 2 points. If the same thing happens to Nyx, I'm going to give that 1 point. So again, here, someone's living, but it's a little bit better if Rask is the one with the ult than if Nyx is the one with the ult. All right, so, you can check that at equilibrium, each player plays both of these. Both strategies are mixed at equilibrium. So let's use the indifference principle to figure out what the equilibrium strategies are. So let's first figure out how often Lockwood should shoot each. So Lockwood shoots Rask with prob P. So at this point, I would encourage you to actually pause the video and to think about this. See if you can do this alone, but also think about if you have an intuition about what the Nash equilibrium is going to be. All right, so the EV when Su ults Rask is, well, probability P, she gets a payoff of 2, so it's 2P, and then -5 times 1 minus P, because that's where Lockwood shoots Nyx, so we're down here. The EV of Su ults Nyx, well, that's -5P right here, and then plus 1 minus P. All right, so we equate these. So 2P minus 5 times 1 minus P is equal to -5P plus 1 minus P. All right, so let's move things over. We've got 7P equals 6 times 1 minus P. So 7P equals 6 minus 6P. So 13p equals 6. So p equals 6/13. All right, so now let's go and remind ourselves what p meant. So Lockwood shoots Rask with probability p. So that means that Lockwood shoots Rask a little bit less than 50% of the time if the ult is better on Rask. So Lockwood goes for the worst ult target a little bit more often. Now let's figure out what Su-Ren does. So here we have to look at Lockwood's EVs. So suppose Su ults Rask with probability Q. All right. So the EV of Lockwood shoots Rask. Well, when Lockwood shoots Rask with probability Q, the payoff is 2, and with probability 1 minus Q, the payoff is minus 5. And then EV when Lockwood shoots Nyx, well, with probability Q, the payoff is minus 5, and with probability 1 minus Q, the payoff is 1. So these are pretty similar, right? They're in fact exactly the same. So what we get is that Q should be 6/13 as well, because again, 2Q minus 5, 1 minus Q, 2P minus 5, 1 minus P, minus 5P plus 1 minus P, minus 5Q plus 1 minus Q. They're exactly the same. So of course we don't have to solve the system again. So that means that Su ults Rask with probability 6/13. So that means that Su ults the worst target more often. So now if you look at in-game situations, you can try and figure out what side of this your opponent is on. So for example, a lot of people will try to take the better option whenever they're faced with something like this. Another situation where the payoff matrix might be similar is when you have to dash, and you can choose to either dash onto the health or dash like somewhere random. A lot of people are going to choose to dash to the health, even though this kind of analysis will tell you that at equilibrium, you're dashing not to the health most of the time. So if you can figure out what side of things your opponent is on, then you can quickly try and maximally exploit them.